In this tutorial, you'll learn how to solve equations by clearing them of fractions or decimals. So if I were to ask you which equation you would rather solve, which one would you pick? Probably the one on the right. But what if I told you they're the exact same equation? Kind of like how these are the exact same fraction. So when you're renaming fractions, you multiply both the numerator and denominator by the same value. And the same is true when you want to rename a whole equation. You can multiply every term by the same value. Let's get started. Pause the video if you'd like to get an overview of the lesson. Once you're done looking at this example, you can unpause the video. Alright, let's get started. In order to clear a fraction from an equation, you need to multiply every single term by the least common denominator, or LCD. And in order to do that, you have to look at all of the denominators. All of the denominators. Even the invisible ones. So in order to find the LCD here, you're going to have to find the least common multiple, or the LCM, of these values. So 3, 5, and 1 have a lowest common multiple of 15. So I'm going to multiply every single term by 15. And there's a couple of different ways I can write that. I can say I'm going to multiply this entire side by 15 and this entire side by 15. Or I can break it up to every single term, like this. I kind of write it up above, but it's the same as really just writing it to the side, which is what's happening, right? But I prefer to write mine up above. And the reason why I do that is because when I'm going to multiply 15 by a fraction, I'm actually going to do some multiplying, but I'm also going to do some dividing. And sometimes I prefer to do my dividing first. So 15 divided by 3 is 5. And 15 divided by 5 is 3. And 15 divided by 1 is 15, so I'm not going to touch this last one at all. Now I'm ready to do my multiplying. 5 times x is 5x. And 3 times x is 3x. And 15 times 8 is 120. Combine like terms. Use your inverse property here. And that's it. Pause the video if you want to take a longer look. Let's try another problem. Again, look at all of the denominators. This time we have a repeat denominator. It's 4, 1, and 4, which really means just 4s. So since they all have the same value, I'm going to multiply every term by 4. Again, sometimes you can reduce first. Makes your multiplying easier. Use all your inverse properties. That wasn't so bad. Let's try another one. It's getting a little longer now. But don't forget, you have to look at every single term. So it looks like I have 4s, a 1, and a 3. So 4 and 3 have multiples of, let's see, 4, 8, 12, 16, up, and they both have a multiple of 12. So that's my magic number. Don't forget to multiply every single term. I'm going to choose to reduce first and multiply second. 3 times 7 is 21, and this term has a y. 3 times 1 is 3. 12 times 2 is 24. This one also has a y. And 4 times 5 is 20. And don't forget, if your problem started with a fraction, don't change your answer to a decimal. So we're going to leave it in fraction form. All right, one more. Numbers are getting a little bit bigger, but the method is the same. So I'm looking for common multiples of 12 and 15. Now when I'm trying to find my common multiples, the fastest way is to start with the multiples of the larger value, and then you can see if they match any of the smaller value. So 15 times 1, 15 times 2, times 3, times 4, and there's my winner. 12 also goes into 60. So 60 is my LCD. And don't forget, you need to multiply that last value. So again, I'm going to reduce first, and then I'm going to multiply. 5 times 1, this value has a t. 4 times 1, this value also has a t. And 129 times 60, I need a calculator for that. 7740. Combine like terms. Use my inverse operation. And get your final value. Again, pause the video if you need to take a longer look. Let's take a look at this one. That looks pretty long. But again, I'm only interested in the denominators. So I've got a 3, 12, and 4s. So that makes my LCD 12. Don't forget to multiply every single term. Even if it's not a fraction, it gets multiplied. Alright, 4 times 5 is 20. 4 times 2 is 8. This one has a variable. 1 times 25. 3 times 5 with a variable. And 3 times 3. Alright, let's see what we have here. $34. I'm going to subtract 8x. I'm going to subtract 34. Divide by 7. And I get a -2. Not so bad, considering when this problem started, it looked pretty nasty. So x is -2. Alright, I think you're ready to try some on your own. Pause the video now. Alright, hope you did well. Let's check your answers. Please pause the video to check over your work. Alright, let's try one more challenging question. What happens if your terms have parentheses? Now let's repeat that. You see that minus sign? This is an expression, and it certainly looks like it has two terms in it. But when it has a coefficient, that makes this entire quantity one term. And you're only allowed to multiply a term once, so I can't multiply this and this and this. So that's what makes this problem different. When I look at my denominators, I'm only allowed to look at the coefficients, right? I'm not looking at this because it's a fraction. I'm looking at it because it's a coefficient right now. And its denominator is 4, and this has a denominator of 1, which makes 4 my LCD. So when I multiply each term, I'm only going to multiply that front coefficient, and that's it. So look what happens in this problem. I'm going to multiply 4 times 3/4. 4 times 3 is 12. 12 divided by 4 is 3. But I do not multiply the quantity. It remains untouched. So again, 4 times 2, which is my coefficient, but I do not multiply the quantity inside. And now I just solved this problem using distribution. 24 times 3 is 72. 8 times 3 is 24. 8 times 5 is 40. And 8 times 1 is 8. I'm going to add 24c to both sides. I'm going to subtract 8 from both sides. Divide both sides by 64. Alright, let's take a look at this problem. Remember that you need to look at all of the terms separately. One term, two terms, three terms. So this has a denominator of 2, 1, and 1, which makes my LCD 2. Again, if you have a coefficient in front of a quantity, that's a single term. So I'm going to multiply just that coefficient by 2, and each of these separate terms also by 2, the LCD. This gives us a 1. And over here, we get a 4x and an 8. Again, a 1 coefficient doesn't do much, so let's rewrite that. Subtract 4x from both sides. Again, I'm going to leave my 1 coefficient invisible here. Pause the video if you need to take a longer look at this question. Let's see if you're ready to try one on your own. Pause the video now and give this a try. Okay, let's check and see how you did. Bet you weren't expecting that answer, huh? Well, we've covered that topic already, so this should look familiar to you. Maybe you even saw the answer a little bit sooner. Let's take a look at one more challenging question. What happens if your numerator has an expression? Well, you still concentrate on the denominators, even the ones you can't see. So it looks like I have 6 and 10, which gives me an LCD of 30. Now when I multiply each term by 30, if your numerator is an expression, then you're going to wind up distributing that value. Just like this. 5 times the entire numerator. And 3 times the entire numerator over here. 5 times 2 is 10. 5 times 7 is 35. Negative 3 times 2 is negative 6x. Negative 3 times minus 9 is positive 27. Now let's see how all this combines. So 10 minus 6 is 4x, and 35 plus 27 is 62. And subtract 62 from both sides. Here, that gives me a 28. Pause the video if you need to take a longer look. Alright, let's get on to the second part of the lesson now. Which one of these would you rather solve? Again, would you be surprised if I told you they're the same exact equation? Well, they are. Just like you can rename the fractions, you can rename the decimals. If you'd like a little preview, pause the video now to look at this example. Alright, let's take a look. In order to clear an equation of decimals, you need to multiply each term by the power of 10, of the longest decimal value. So let's look at our decimal values. That's one place, that's one place, that's one place. So they all have the same amount of places, which makes the longest place value 1 power of 10. So I'm going to multiply every single value here by 10 to the first. And when I do that, I'm going to move that decimal one place value. One place value, one place value, one place value. And now use your inverse operations. Pause the video if you need to take a longer look. Now let's try it again. Look at every single term and find the longest decimal value. 1 place, 3 places, 2 places, 3 places. So 3 is the longest decimal place, so we're going to multiply everybody by 10 to the third power, also known as 1,000. And when I multiply by a power of 10, I move the decimal point. So this decimal point is going to move 3 times. 1, 2, 3, filling in those empty spots. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Oops, I don't know where I got that 5 from. That was weird. Add 6. Subtract 80x. Divide both sides by 20. Not so bad. I think you're ready to try 2 on your own. Pause the video. Alright, let's take a look and see how you did. Hope you got them right. And that concludes our lesson on clearing fractions and decimals to solve equations.